Do my highlighting thing because I'm the best math teacher ever. Okay, complex fractions are just fractions in fractions, in fractions, in fractions, in fractions. Ba-da-da. Ba-da-da-ba-da. And this is a mixed number, and mixed numbers for the most part are terrible. The bad way is going to result in some dead puppies. Do you guys ever watch those? Okay. Hello. Let's look at lesson 11-8. I am in the book, page 612. We have 1, 2, 3, 4. Okay, 4. 4 examples to take a look at and their associated check your progress problems on mixed expressions and complex fractions. And we're going to continue our analogies to fractions. And today, mixed numbers with these, because remember, these rational expressions that we've been studying all chapter long often behave much like, if not precisely the same as, fractions. So, for example, the book shows you 2.5. And this is a mixed number. And mixed numbers, for the most part, are terrible. Usually we want to turn them into improper fractions, right? And so we kind of do this process where we multiply the 2 times the 2 for some reason, and that would be 4. And for some reason, then I keep saying for some reason, we add that to the numerator but keep the denominator the same. And so we would say 2.5 is the same as 5 over 2. Or to pick an example with fewer numbers in common, let's say we had like 4 sevenths. 3 and 4 sevenths. Again, we would take the 3 and the 7 and multiply them together and get 21. We would add that to the 4 that's already there in the numerator and, of course, keep our denominator the same. And so then we would say that the mixed number 3 and 4 sevenths is the same as the improper fraction 25 over 7. So first of all, it's worth understanding, if you haven't thought about it before or don't remember doing it since 4th grade or whatever, what are we doing here? When we say that 2.5 is the same thing as 5 halves, what we're really saying is 2 plus 1/2 is the same as 5 halves, right? And so we get a common denominator by multiplying 2 over 1 times 2 over 2. That's where the 4 is coming from. And because we got a common denominator, that's where that denominator of 2 comes from. And then, of course, we end up with 5 over 2. Same answer either way, right? Same thing down here, 3 and 4 sevenths is literally 3 plus 4 sevenths. We treat the 3 as the fraction 3 over 1. And we use a common denominator of 7. So we multiply by a form of 1, 7 over 7. And that's where we end up with 21 over 7 plus the 4 over 7 that we already had. Gives us our answer, or I shouldn't say answer here, gives us our improper fraction, 25 over 7, right? So although you've probably long ago forgotten that this is why mixed numbers and improper fractions have the equivalences they do, that is why. And that's going to inform our process today on mixed expressions. So what's a mixed expression? Well, again, it's basically the same thing as a mixed number, but we start throwing some variables in. So the book uses the example 3 plus x plus 2 over x minus 3. Now it happens to be that the variable part is entirely in the fraction, in the rational expression, but that does not have to be the case, as we will see here in a few minutes. It can be anywhere, and what we want to be able to do is turn this into or express it as something over something. In fact, if you think back to what I just showed you about 30 seconds ago, you can probably already tell that the second something is going to be x minus 3. That original denominator, whatever it happens to be, is going to serve as our common denominator as we combine these expressions. So I think that's enough of an introduction. Let's jump right into example 1, where we have the mixed expression 3 plus 6 over x plus 3. And again, what we want to be able to do is state this as a single expression, something over something. So that's what we're going to do right now. Just like we did on our examples above, first thing we want to do is take the whole number part, which in this case is actually the whole number 3. Again, it doesn't have to be. It could be a variable expression. Certainly it could be negative. But we're going to take that whole number part of 3, express it over 1, and then we're going to ask ourselves, what would be the common denominator? Now, both based on what I said just a few minutes ago and based on our last lesson, if we simply have denominators of 1 and x plus 3 that otherwise have no common factors, I mean 1 obviously goes into itself, but it's not helpful to us, our common denominator simply ends up being the product of the 1 and the x plus 3, namely x plus 3, right? 1 times x plus 3 is x plus 3. All of which to say, basically, just take whatever the denominator is, multiplied by it over itself to the whole number part. Of course, up here, because this is not just a number, because it's a binomial, we're going to end up distributing, and so we get 3x plus 9 over that common denominator of x plus 3, plus the 6 over x plus 3, and then that would be the same thing, obviously, as 3x plus 15 over x plus 3. Now, at this stage, you are going to be tempted to cancel, right? And there's a good way to be tempted to cancel, though still unnecessary, and there's a bad way to be tempted to cancel. The bad way is going to result in some dead puppies. 3 goes into 15 5 times. X goes into x 0 times. Oh, wow, that's nice. This expression simplifies to 8. If we go back here and we say, let x equal 10, right? Then this would be 3 plus 6 over 10 plus 3, right? Or the mixed number, 3 and 6/13.
Does that look like 8 to you?
No, that's not the same as 8, right? This is not the proper way to cancel. This is going to get you in trouble. 3x plus 15 over x plus 3 will only cancel if we have common factors. That is, if we could factor something out of both numerator and denominator, that itself then, because it was in common between the two, canceled out to be 1. There is something we can factor from the numerator here. You might notice that a 3 comes out, but it leaves x plus 5. And if we tried to simplify further from here, eventually we would just get back to something that looks like the original expression anyway. So for a variety of reasons, it is unnecessary. It will not work. The answer here simply is the improper. No, it's just a rational expression now. So that is a difference. There's no such thing as an improper rational expression. The answer is the rational expression 3x plus 15 over x plus 3. Take a moment and work out Check Your Progress 1A and 1B for yourself. Just jumping in here for a second to note, you can see here the fractional part has come first. Actually, I'm going to do this with you guys. 2 reasons. Check Your Progress number 1A, I just noticed the fractional part comes first, which is just a little bit weird. That wasn't a big deal. But then also our whole number part has a variable here. On 1B, it involves some subtraction, so we're going to have to be really careful with that. We don't typically have mixed numbers with subtraction, although technically speaking, we could. But anyway, so let's go ahead and do these together. Hopefully you notice, that this 4y plus 8 could be factored. We could express that as 6y over 4 times y plus 2. And there's not a great reason to do that. I would say there's one good reason, but let's ignore that for a second. Let's just come back to the original expression here and say, you know what? Let's just call that 5y over 1, and let's multiply by 4y plus 8, that denominator from the fractional part from the rational expression, over itself, of course. So what that is going to give us is the original fraction, or rational expression, unchanged. And then here, of course, we end up with some distribution, 20y squared plus 40y, and it's all over. 4y plus 8, the common denominator. When we combine everything and list it by descending powers of y, we get 20y squared plus 46y, all over 4y plus 8. Now at this stage, you should realize, oh, we've got a common factor here. 2y goes in, leaving 10y and 23 for the numerator, and 4, as we saw over here, comes out of the denominator, leaving y plus 2. Not a ton of cancellation we can do with that, but the 2 and the 4 do turn into 2, and so we get y times 10y plus 23, the quantity, all over 2 times y plus 2. And not that we would have to do this, but we could expand that back out. 10y squared plus 23y over 2y plus 4. But again, either one of these answers would be fine. Now I say, going back here, there was a reason we could have done this. You might have noticed, oh, right from the beginning, that wasn't really in most simple form. So it was 3y over, if we multiply it back out, 2y plus 4 plus the 5y. If we treat that now like the thing that we're going to multiply by our common denominator divided by itself, you might notice we end up with 3y over 2y plus 4 plus 10y squared plus 20y over 2y plus 4. And of course, combining that would get us right over here to 10y squared plus 23y over 2y plus 4. So similarly with fractions, if you simplify earlier in the process, you don't have to simplify later. So, we saved all those steps over here. We didn't have to do anything to get that answer, 10y squared plus 23y over 2y plus 4. But that's really the only benefit simplifying earlier is going to bring you. And looking ahead to 1b, although we can factor something out of the denominator there, you might notice 5x and 10 have a 5 in common. It's not going to end up being helpful in the problem. So let's not do that. Let's just go ahead and work that out. Again, this one has a minus sign. That's why I want to look at it with you. 15 minus 17x plus 5 over 5x plus 10. Treat the 15 as 15 over 1. Common denominator will simply be 5x plus 10. Make sure to distribute. So that gives us 75x plus 150 over 5x plus 10. What are they watching? Minus 17x plus 5 over 5x plus 10. 75 minus 17, I'm looking at the x's here, is 58. 150 minus 5, again, we're subtracting everything. Use parentheses if you need to remind yourself of that. Is 145, and the denominator is 5x plus 10. Now again, it is totally fine to just leave your rational expression looking like that. However, I said a moment ago, 5x plus 10, we do have a common factor we can pull out. It turns into 5 times the quantity x plus 2. And oddly enough, there is a common factor between 58 and 145. 29 happens to go into both of them. So we end up with a 2x plus 5 there. However, from here, nothing else cancels. Again, I know I don't have any puppy killers thinking I should be canceling those 5s. There's that big plus sign on its top, which would stop me from doing that. So even if I did try and factor out, it doesn't end up really looking any better. Either of these two answers is acceptable. Questions? Thumbs up, thumbs down? Did I get you? Did anybody put their thumb up or down right now? I hope so. Okay, complex fractions are just fractions in fractions. So that's what I'm looking at on page, page 613. If we have a fraction in a fraction, a over b, which itself is the numerator, and the denominator, which itself is the fraction, c over d, this is equal to a d over b c. And the book, I think, gets into why, but the basic idea is our keep, switch, flip, right? This means the same thing as a over b divided by c over d, which itself is the same thing as a over b times d over c. And then that is how we end up at AD as our numerator divided by BC. So that's what we call a complex fraction. We can do it with numbers, we can do it with algebra. It makes no difference. In example 2, we have, refer to the application at the beginning of the lesson. How many cookies can Caitlin make with 2.5 pounds of dough? The average cookie requires 1.5 ounces of dough. Oh, and they did the work for us. They just said that was 2.5 pounds divided by 1.5 ounces. I don't love the way that they did this. Let's actually try and think through what's going on. So we have two quantities, we're told. 2.5 pounds of dough, and then every 1.5 ounces of dough makes 1 cookie. And we want to turn pounds of dough into cookies. This is a great candidate for dimensional analysis. Let's express these mixed numbers as fractions. So that's 5 over 2, right? And that's 3 over 2. And so really what we're saying is, all right, so we have 5 over 2 pounds, and we want to turn this into cookies. We're going to do it with some unit converters. First of all, one of our unit converters is how we end up with cookies at the end of this process. We know that 1 cookie corresponds to 3 over 2 ounces. But notice, pounds and ounces don't cancel. Now they're measuring the same kind of quantity, so with a unit converter they can cancel, but they don't naturally cancel. Because we have pounds in our numerator, we need to put it in the denominator to cancel it out. And we also want to eventually cancel out ounces. And so since it was already in the denominator, we put it in the numerator to cancel it out. And then we just have to write down the relationship. There are 16 ounces per 1 pound. And so when we multiply all this out, we get 5 over 2 times 16 divided by 3 over 2. I'm running out of room here. So when we multiply all this out, we get 5 over 2 times 16 in our numerator and 3 over 2 in our denominator. 5 over 2 times 16, we can actually go ahead and multiply out. 2 goes into 16 8 times. 5 times 8 is 40. But then 40 divided by 3 over 2, we're going to have to do a complex fraction kind of thing. So 40 over 3 over 2 is the same thing as 40 times 2/3. And again, that's really 40 over 1, right? 80 over 3 cookies. 3 goes into 80, 28, 29, 26. 26 times and 2/3 left over. So at 1.5 ounces per cookie with 2.5 pounds of cookie dough, we can make 26 and 2/3 cookies, which is making me hungry for cookies right now. Take a moment and figure out your own stuff on Check Your Progress number 2. All right, you can see my answer there. I am getting that with these circumstances, 12.5 pounds of flour, 3 3/4 cups of flour to a pound, and 1/3 of a cup of flour per tortilla, that we can make 140 5/8 tortillas. And again, I did it with dimensional analysis. Love that. Love dimensional analysis. Okay, so let's simplify some weird-looking monomial expressions using these same techniques. A bunch of keep, switch, flip just looks a little bit different from a few days ago. Keep, switch, flip, essentially keep, switch, flip, right? That fraction bar is division. So this is going to be x squared y squared over a times the reciprocal a to the third over x squared y. A goes into a to the third, leaving an a squared. X squared cancel. Y out of y squared leaves a y. Do my highlighting thing because I'm the best math teacher ever. And write that down. A squared y is the product there. And that's that. That's example 3. Ooh, I even got it right. Nice. Take a moment and work out check your progress 3A and 3B. Okay, I noticed that, I was just saying to some friends the other day, recording these videos have given me quite a bit of insight into some of my verbal tics, and honestly, I don't know how you guys have put up with me for 2 years. Okay, I am looking at Check Your Progress 3A, and I got BG squared divided by H squared I. You'll notice I did get to do a little special cancellation. H over H to the third. Remember, when these cancel, the result goes where the larger power was, which in this case was the denominator. Of course, don't forget the I doesn't cancel with anything, but it is still there in the denominator. Check your progress 3B. I got 3mn to the 9th over 2p cubed, and you want to be very careful with a lot of your cancellation. So notice this p squared and this p don't cancel because they are both in the denominator. Same thing here with the n to the 5th and the n to the 4th. We're multiplying them, not dividing them, and so they do not cancel. They just combine and make p to the 3rd in the denominator, n to the 9th in the numerator. And I don't think I missed anything else, so that's that. Okay, example 4. How are we on time? trying to get this under 25 minutes. I bet I can cut enough material to make that happen. Oh, maybe not. All right, so example 4, we have a complex fraction, but the complex fraction itself has a mixed expression. So our numerator is a minus 15 over a minus 2, and that whole thing is divided by merely a plus 3. Okay, so not the most complicated thing in the world. Let's deal with just the numerator first. If we have a minus 15 over a minus 2, remember this was the very first thing we did in today's lesson. Let's multiply that first part of the expression. Here it's just a variable by a minus 2 over itself. If we do a little bit of distribution here in the numerator, a squared minus 2a over a minus 2 minus 15 over a minus 2, and finally a squared minus 2a minus the 15. Combine it into a single expression over a minus 2. So this is this, right? And so let's take that back here and rewrite it now. A squared minus 2a minus 15 over a minus 2. And let's remember that the whole thing was itself divided by a minus 3. Keep switch flip time. A squared minus 2a minus 15 over a minus 2 is the keep. Turn that division, that's what that fraction bar is, into multiplication. And then use the reciprocal of a minus 3. What on earth is the reciprocal of a minus 3? What's the reciprocal of 10? 1 over 10. What's the reciprocal of negative 18? 1 over negative 18. What's the reciprocal of a minus 3? 1 over a minus 3. Something interesting happens here because a squared minus 2a minus 15 is itself factorable. It turns into a minus 5, a plus 3. We already had an a minus 2. Wait, did I do that wrong? Yes. Why didn't you guys tell me? It's a plus 3 in the denominator. A plus 3, a plus 3, a plus 3. Which means that the a plus 3's cancel, and my expression turns into a minus 5 over a minus 2. And that's that. Take a moment and work out. Check your progress. 4a and 5b. That's the typo my book has. I don't know what yours says. Check your progress. 4a and 4b. So I'm going to pause here to give you a classic math teacher trick. Our numerator, the mixed expression, you can see should have turned into 2c squared minus 5c minus 3 all over c plus 7. And then I'm multiplying it by the reciprocal, 1 over 2c plus 1. The c plus 7 is not going to cancel. I mean, it could, I guess, but 7 is not a factor of 3, so that's not going to happen. But if I see something like this, and I think, oh, I bet I'm going to have to use box method, 2c squared and a minus 3. Although it would not be hard to do so, I can be pretty confident that this 2c plus 1 is going to end up being one of the factors. And if it is, that means that c and minus 3 would have to be the other factor. And when I multiply that out, I can see, oh, that does work, because 1c and negative 6c make negative 5c. So I can use the fact that math teachers are lazy to my advantage. So we get 2c plus 1 times c minus 3. And again, that's this right here being factored by box method into this right here. And all of that is still over c plus 7 times 1 over 2c plus 1. But I'm going to cancel now. The 2c plus 1, 2c plus 1. And that's how I end up with simply c minus 3 over c plus 7. Earlier, my answer for Check Your Progress 4A was 3 over the product, b plus 3 times b minus 4. That is lesson 11-8, mixed expressions and complex fractions. We are moving along, right? Doing more and more with these rational expressions. We want to be able to do basically everything we can do with fractions with rational expressions, fractions that have variables in them, including tomorrow, the last lesson, solving equations that involve these rational expressions. Something to look forward to. Test is coming. Make sure you are staying on top of the homework. I am happy to get together with you. Comment down below, like the video, subscribe, do whatever all the YouTube people say to do.